Welcome to this session. We have a problem for us to evaluate. So the integral of dx over square root of 4 plus x squared. Now, the solution of this integral will be obtained by trigonometric substitution. And because we can see that square root of 4 plus x squared is of the form square root of a squared plus x squared, then we need to make a trigonometric substitution of the type. Remember, when the discriminant was x squared, the root was a squared plus x squared, then the correct form of substitution to pick was x equals to a tan theta. So this is the correct form to pick whenever the integrand is of this form. So it's not hard to see that 4 plus x squared equals to square root of a squared plus x squared implies that a is 2, because 2 squared is what gives you 4. So then we have x is equals to 2 tan of theta. Now, 4 plus x squared will be the same as 4 plus 2 tan theta squared. Because we have said that where there's x, we put 2 tan of theta. And this will give us 4 plus 4 tan squared of theta. Which means 4 plus x squared is the same as 4 into 1 plus tan squared theta. But by definition, 1 plus tan squared is sec squared theta. So which means that the square root of 4 plus x squared is the same as the square root of 4 sec squared theta. And this we can write it as 2 square root of sec squared is sec of theta. And so where the square root of 4 plus x squared will be replaced by this. And from what you have said here, this implies that dx is the same as 2. Integrating tan, you get sec squared, and then the theta. So integral of dx over square root of 4 plus x squared will be the same as the integral. Where there's dx, we put 2 sec squared theta d theta. And the square root of 4 plus x squared, we have found the answer to be 2 sec theta. And you see by definition, 2 and 2 cancels out, 1, and then this goes. So we'll have the square root sec theta d theta. And by definition, the integral of sec theta d theta is nothing but ln of sec theta plus tan of theta, then plus a constant of integration c. But remember, you don't stop here because theta is our own creation. Theta was our own creation in the substitution. So the problem was in terms of x. So, but since we have said that x is 2 tan theta, then it means that tan of theta itself is x over 2. Then you draw a right angled triangle. Tan is opposite over adjacent. So by Pythagoras theorem, this will be 4 plus x squared, 2 squared plus x squared, square root. Which implies that sec theta is the same as sec is 1 over cosine, and cosine is adjacent of hypotenuse. So sec will be hypotenuse over adjacent. So square root of 4 plus x squared divided by 2. So everything in the integral, we have it. Sec theta, we have it here. Tan theta, we have it here. So therefore, the integral dx over the square root of 4 plus x squared will be given by ln of sec theta, you put square root of 4 plus x squared divided by 2 plus tan theta, you put x over 2, and then plus constant of integration c. So that is the solution to that given problem. Thank you.